I'm Caroline Elliott. I'm the Executive Director of CREA, the Academy for Education Alliance. I'm a table over there. Always take an opportunity to share information about our organization. So we'll get right to the student presentations, but en route, I just want to give you a little bit of information about CREA and what role we play in this and what we do in the community. Our goal is to really inspire people to care about the natural world, and we do that by trying to connect people with nature. And this whole program with Glenn's class is one of a number of ways that we do that. This is the Ecology Center. I don't know if any of you have been to our Ecology Center, which is located at the Cadet River Nature Preserve. This is where the students came every week for 8 weeks in the fall of 2021. This is the interior of the building. We have a lot of natural history displays, a lot of amounts of native birds and mammals, and a lot of educational displays. The Ecology Center is open every Sunday from 12 to 2, so if you ever want to come and drop in and check it out, we have some pretty cool stuff there. We run school programs in SAB 75 and Brunswick. We work with elementary school classes. They come to the Ecology Center for a half day to do hands-on experiential science learning. And these pictures show you some of the things they do. They scoop invertebrates from the pond. They grade rocks into sand and learn about erosion and weathering. And the kids love these field trips. You may have heard about them when your kids were younger. We run a nature immersion summer camp, and our summer camp this year, you know, it's not a huge summer camp. This year we're running for 7 weeks. We have 32 spots each week, and we sold out in basically the first 30 minutes of registration. So that tells you something about the demand for just getting into nature and off screen. And we do guided nature walks in the preserve, usually in the spring and fall, sometimes in the winter, snowshoes. And just a little bit about this program, we've been partnering with Glenn to do this program since 2007. The students do their research at the preserve. They come for 6 to 8 weeks, weather permitting. And it's pretty cool to see the evolution of the students from the first time they visit. They tour the preserve and the different sampling sites. To by the end, they show up, they go grab their equipment, they head out, they collect their data, and they look like scientists, and it's pretty fun to watch that. Our role is Glenn provides the students and all of the guidance, and we provide some of the equipment, and we work with Glenn to find mentors in the community, and we provide logistics and moral support. So this is a picture from the first day, part of the tour. This is our vernal pool. And this is what it eventually starts to look like with the students using various types of equipment to collect their data. That's David Reed, who's here tonight. So I just wanted to give you a taste of what this work looks like. That's on the heath, collecting, taking inventory of plants. And I just wanted to take a moment to thank our mentors. Mentors, if you're here, can you raise your hand so that people can, Fred and David and Meg and it's a real labor of love. They show up every Thursday for an hour and a half, and the weather's not always nice, and the data doesn't always cooperate, but it's really a wonderful thing that they do, so a huge thank you to them. A big thank you to Stantec, who prints out the posters for us, which was also professional. And then a big thank you to Glenn. This program would not happen. it's really, this is a unique opportunity that most high school students do not have. And it's, we know of students who have graduated from this or have gone through this program, and some of them go on to become environmental engineers. And one of them I just talked to the other day, who may be doing a presentation for us in the fall, is getting his PhD in predictive ecological genomics. So, anyway, it can go anywhere. So that is it. There's class of 2021. I'm going to turn it over to Glenn.
Right. Thank you. Thank you, Caroline. Korea is very fortunate to have you as an awesome executive director. And thank you, parents, for being here, and friends and guests for all being here tonight. I never get great students, it's great. There's always great parents too, so thank you very much. And thank you all, the advanced biology students, for being here, for all you did and all the hours you put in, and now willing to give up a little more time to share your wonderful findings with everybody. This meeting, as you know, got changed. It was originally scheduled for January, and it was also not a good time with the whole COVID variant. We had to find another time to do it, and I think things have really worked out nicely. We wanted to make sure it was between the sports seasons. We wanted to make sure it was not on St. Patrick's Day, which is a week from today. And the date really seems to have worked, and it's great to see everybody here. I have to check your date about 2007 because
I checked our newsletters. I found a reference to it in our newsletter.
Right, there may not have been a reference before that.
Oh, you
This is
think
my
it's
seventh
here?
This is our 17th year
Oh.
doing this, so we'll have to check. In my mind, it's the 17th, so we'll have to check on that. But when it started, I always like to say when we started, this is Korea's longest running program. Because when it started, there wasn't even an ecology center. The bus drivers would look forward to going four-wheeling with their buses down the road to get there. They said they never had a chance to four-wheel a bus before. And the Korea equipment with no place to store was actually being stored at Ararat High School for a short period before the ecology center got put together. The first presentation was held in my classroom, and very few could attend because of the size. But now, of course, we have this wonderful venue, and it's great to see everybody here. As you were mentioning, Caroline, we really don't know we know some of the effects of this because you said you've been in touch. I'll have to find out who that genomics student is who's going to be presenting in the fall. But sometimes we have rare opportunities of seeing it before the students even graduates. So in addition to the projects being presented tonight that were done this year, we have a couple seniors who were involved with this. Actually, there are three seniors, one couldn't make it tonight, who were involved with this project 2 years ago and were inspired by it. We saw and we're going to see what that inspiration is even before they get to college. And they happen to put together, design, and put together an award-winning ROV, remotely operated vehicle. I like to think of it as an underwater drone, but used to do some special studies that was inspired by their work here at the Heath and all that. They're going to be the last group to present tonight. As always, there's a variety of topics being covered tonight. This really, in my mind, highlights what I've always understood Korea to be about. Helping young people, helping all people get to know the environment a little bit better, but also having students give back to the community and share what's going on, their findings about the local environment. We're going to be treated to that tonight. In some cases, some of these projects are ones that happen every year because they're so important, like the water quality of the river. In other cases, sometimes a project gets resurrected after 12 years of kind of lying in the dust. And then we have the bird group tonight. There hasn't been a bird study done by the high school students in 12 years. And actually, interestingly, Caroline's son was involved 12 years ago. Caleb,
Really?
with his was the last year to do the bird study. So, whatever, and the most important, as important, is that all these projects have wonderful posters that are going to be displayed on the CREA website. And you can look at years of posters and findings, and also the reports are very important reports, and their data is going to be part of the archives of the Gettysburg Education Alliance. So, without further ado, we're going to hear from the students first, with giving you a little bit of background about their projects, but not letting you know their findings, because we want to encourage you to go visit them at their posters later on to see what they actually came up with. So, let's, we're going to start. So you have something going on, okay?
No, I just advanced the.
We're going to start with the bird group coming up first, and this is Anya and Rose coming on up, and they were mentored by Meg Holland, who actually is a Highland Green resident, kind of the hometown hero of all the mentors, because you didn't have to go too far to help out. Here you go.
Thank you. I'm Rose Tuttle, and I'm on your Topsham. And we did the pet hunter reserve bird study. So our purpose was, well, actually we had a couple different questions. But our first question was, how do bird populations change over time? What habitats are preferred by bird species? And also, what temperatures and weather conditions are preferred by birds as determined by their number, the number of birds we've seen, and also the different types of species we've seen in these places.
And based on these purposes, we hypothesized that birds prefer warmer and wetter areas over colder and drier areas, and they would prefer wooded areas over more open.
Yeah, and as you guys already know, we haven't done this study in 12 years. The one done in 2009 was a little bit different because they had a different question, but yeah, it was really nice to be able to do this again. Some other things too, you can see on our poster we've got the trails used. You can see with that highlighted blue right there, that was the sort of trails we walked along to get a variety of different habitats, such as the deciduous forests, coniferous forests, and also some bodies of water, like a river. There's also a pond. So make sure we cover all our boundaries in terms of habitats and such. And those trails included the Brunswick Trail, the Cathay's River Trail, and finally the Island Trail. So we recorded, weather conditions, the kinds of birds, the amount we were seeing, and also, the behaviors as well.
And here are a few pictures of us in action. All the way up there, you can see all four of us, including Meg and Ms. Evans, who are our wonderful mentors. And we have a few action shots of Rose and I looking through binoculars. And of course, thank you to CREA for supplying us with our support.
Yeah, one more thing too. I have a couple fun stories. So the first one was Meg always carried around this little bird whistle. It was almost like a bird whistle. It was like this little it was like this little screw thing that you could pull, and it sort of scraped along it was like plastic, right? Yeah. But it would, yeah, it made a squeaking noise, and so she would use it a lot, and we would all turn around and look, because we thought it was a bird. And you'd be like, where is it? Where is it? And then you're like, oh, it's just Meg. and then the other thing too is Mr. Evans taught us how fishing, which is sort of another way to call for birds. And so you sort of make a shh-shing sound, but you have to heat of it, so it's like shh. And it worked. There was a lot of birds that would come around and be like, what's going on? What's going on? we got a lot of birds that way. And yeah.
And here are also some of our data tables, and if you want to figure out what we found out, come by our poster.
Yeah, thank you so much.
Next, we have the water quality itself, which has been a very long-running program. It's our project. It seems to go almost every year. And according to people from CREA, the most asked about project is this one. There's always questions like, oh, there's foam in the river, there's something wrong with the river. And this study that's done every year helps answer those questions. So we got Ben and Donica up here to tell us about water quality.
Okay, hi, I'm Danica.
And I'm Ben, and we
study the water quality of the Catherine River?
So our whole main purpose for doing this was we wanted to see if the river was healthy, and we wanted to look a little bit at last year or 2 years ago in their testing, they found that the water color was a little bit higher than normal. So we want to look a little bit more into that in detail. We also hypothesized, because of this, that the river quality would be healthier in the faster moving water areas and then in the slower one. And that maybe the soil pH and the leaves could have had a little bit more to do with the water color than we thought.
Yeah, so we ran different tests at 3 locations. We decided to run one test up the river, where it was slower moving, one test at the rapids, and one test beneath the rapids. We ran dissolved oxygen test, alkalinity test, turbidity, conductivity, temperature, depth, speed, and eventually we saw this foam piling up by the river, and we assumed that it was correlated with the water quality. A funny story actually. Danica was wearing sandals one time to our test location, and she slipped and fell into the water. Yeah, she was muddy after that. Yeah, that's it.
Perhaps watching Donica fall in the water, I forgot to just Scott Liddy in back somewhere from Bechtel was mentoring this project. He's mentored it for 2 or 3 years now. We thank you, Scott, very much for that. Mostly tied in with the water quality is, of course, the life of the river. And these are the invertebrates, well, there's fish in the river too, but this group was focusing on the invertebrates. This is Sophie and Grace, and they're going to be coming up here in a minute. But David Reed up front here has been a wonderful jack of all trades in terms of filling in for all different projects. But his true love is really the invertebrates in the river, and he's helped again this year, and we thank him so much for doing that. So, but Grace and Sophie, you want to come on up and tell us about your study?
Hi, I'm Grace, and this is Sophie, and we were the Calumet River Invertebrate Sampling Group.
Hold the mic a little bit closer to your mouth.
And we were testing, our question was, how does a variety of population of invertebrates change from shallow fast water to deep still water, and how does a variety of invertebrates indicate the river's water quality?
And our hypothesis going into this was, will there be more variety of invertebrates in the deeper, slower areas opposed to the faster, shallower areas? We initially thought there was going to be more in deeper, slower. We're going to have to visit it later to see if that's actually right. And so we also want to test their sensitivity to water pollution to help determine the water quality of the river, and if it was good or not.
A little background on our project. So water speeds up through different habitats that can impact the variety of aquatic invertebrates and the population numbers, as well as the water quality is known to impact the types of aquatic invertebrates and their and that they can survive.
And so our procedure is initially we obtain materials, which would be buckets, the nets, the yardsticks, and one time we did lose a bucket, which was an interesting story. It was our fault. So I had the bucket in my hands and I went down to fix the waiter, and it was kind of like a fast, rapid day. So the bucket went away, and David Reed had to go fetch it, and everybody was trying to. It was very dramatic. Wherever it was the bucket, there was running in water. It was crazy. But that only happened on the last day. And so then we would walk from the bus to Korea and the ecology center. Then we would walk from there to the river itself. And so we would put on waders and we were farther downstream from Barnes Lake. And then we recorded the water speed of the fast and shallow area first, as well as the depth, which you can see Grace doing in that wonderful photo, which I took. And then we would get into the water, which was an adventure in itself because there were some days where it was really fast and you can't really see where you're stepping, and so it's kind of just a gamble on if you're gonna like make it out there. And back, which is another thing because on your way back you're holding the invertebrates and you don't want to fall. I did many times. I didn't lose anything, I hope. So, and so then we would use a tight mesh net, which you can see me holding in that photo, to try and collect invertebrates. We would pick up rocks, we would put our hands in there, and we would just try and push any invertebrates into the net like that, where the water would help push it. And then we would place these samples in the observation tray, and we would repeat these same steps for the slower area. But we also had these samplers, which were little metal plates, which we would leave in the water every week, which would collect invertebrates as well. However, sometimes we did lose them due to various factors, whether it be weather or misunderstandings. So then we would search the buckets, which was the most fun part because then you could actually see what we were collecting, and you can see that in that photo. And yeah, it was a really good time, and then we would take pictures of the invertebrates and try and identify them. And that's about it, so it was really fun.
Next group we're going to be hearing from is the forestry group. This is Evan and Isaac, and Kevin Doran is here somewhere. There he is, hiding in the back, sort of. But Kevin is our longest running mentor, and if I'm correct that we've been doing this 17 years, the big plot started the second year, so you've been doing this for 16 years. So, and Kevin, it's outlived his career because he's now retired from the Forestry Service, but loves this project so much he still comes back and helps out. Jane Duggan also has helped with this also from the Forestry Service. So we're going to learn about these plots. These plots just don't exist here at CREA, they exist all over the state. I saw Pat Maloney over here, who is the former executive director of the Maine Tree Foundation. The Maine Tree Foundation catalogs all this data for long-term studies of the forests of Maine. So here's Isaac and Evan.
All right, my name is Isaac Wheeler.
Evan LaRose.
All right. Our project was finding the forest growth, also easily known as State Plot at Cathans for the River Reserve.
The question we were asking was which plot had the most growth in the past 2 years? And we were measuring by DBH, which is diameter breast height. Basically, it's how wide around the tree is.
Alright, our hypothesis was the less mature plot would have more tree growth in the past 4 years than the more mature plot, as measured by DBH, which you'll have to find in a table. Evan will talk a little bit about background.
So about 90% of Maine is covered by forest, and we had 2 plots, and we were only doing about a 1/10 of an acre in one plot, and I think it was a 1/10 of an acre in the other as well. And that is a very small portion of Maine, obviously. But in doing the study, it helps the state program, and basically it helps them have a collective amount of data, and they can accurately predict things in the future. Yeah.
Alright, so a little bit about our procedure. We started by finding the 2 plots, one close to the river and one a little farther away. We then went around in a counterclockwise and measured the DBH of each individual tree, which was pretty time consuming, but we did it. And then we moved up to plot 2 and did the same there. And then at each plot there's 4 small satellite plots, which we just stand around and record the ground cover. And then we did a soil test, and that was pretty much it for that.
This year's study was quite interesting, as last year's study didn't actually happen because of COVID, and so we were actually like studying 2 years of growth as opposed to the typical 1 year of growth. So it was quite interesting.
Alright.
Hello, Mike, coming through on this, yeah. So, yeah, you'll definitely have to check out their results because it was really, and just to add a little bit, and it's actually the year prior to COVID, that project didn't run that year because we couldn't find anybody, nobody chose it. So actually it was a little more than 2 years, which really helped us see something we've never been able to see before between these two plots. And Evan and Isaac were able to discover that. You'll have to find out what they, have to stop by to see what they found. So it was surprising. I mean, when we look at it, it's not surprising in the end. It makes sense, but we weren't thinking about it to begin with. So it was a nice find. Of course, one of the most attractive, charismatic projects, of course, is the mammals. What mammals are at the preserve and what are their habits? And we had 3 students involved with that this year. This was Nick, Nora, and Scotty. And we had the wonderful help from Stantec for many, many years. They're very supportive of this project. Adam Gravel, Gabe Pelletier, both came and helped out. It's involved some remote cameras and some other interesting things. So here we go.
Hi, I'm Scotty Larson. This is Nick and Nora. And our project was on the effects of daylight on mammal activities at CREA. And the problem or question that we came up with, or purpose, was how does the time of day and period of the day, which are day, night, and crepuscular hours. Crepuscular is a time kind of like twilight. And how does that affect the variety of mammal species and number of mammals active at the Caithness Preserve?
So our hypothesis, or what we predicted would happen, was that animals will be most active during dawn and dusk, which also is crepuscular hours.
And our procedure was, so we started by organizing a data table to record the quantity of animals observed according to the species, the time of day, the time period, and the location of the cameras. And then we followed deer trails in wooded areas that led to clearings where the trail splits at the Caithness River Preserve. And we set up Bushnell motion sensitive cameras in those 3 locations, which are located on the map. And determined the GPS coordinates of those locations. And then week by week, we collected the SD cards that were in the cameras, and then we would put them into little drives that we would then search through and look at pictures of the animals. And then we would take out the card, put the information onto the little reader thing, and then replace the card with the new card. And then we would put our observations into the data table that we created.
We also wanted to give a special thanks to Adam Gravel and Gabe Pelletier from Stantec. It would not have happened without you, so thank you.
Yeah, come to our table.
So the last sophomore group to go tonight from the advanced biology class is the Heath group. And the Heath group was a really unique habitat at the preserve that we hadn't really been studying till Fred Chichaki, who's up here, took a special interest in it and thought some pretty neat stuff could be done with it. It was absolutely right. And so we're going to hear about the study this year from the Heath, and then we're going to learn about a project that's inspired by the Heath also. So Aiden, Ethan, and Jacob.
Hello everyone, my name is Ethan, this is Aiden, and this is Jacob. We were working on the Heath plant diversity at Caithness Preserve. Our purpose was we were trying to determine the biodiversity of the fen, and we were also trying to relate the biodiversity to the level of pH in the fen.
So our hypothesis was
as we progress further and further out into heat, the pH will decrease. We also hypothesized that the biodiversity would fluctuate based on the pH. And so in order to do this, we created a 60-meter transect on the heath, which was pretty much just a straight line that went for 60 meters. And then we randomly generated 10 points along the transect using a random number generator. And so what we did is we did a study 1 meter by 1 meter, like quadrat, which was a square. And so we studied each random point along. And we cataloged all the species and the number of those species in each quadrant, and then we also found the pH of each quadrant. And then we determined plant biodiversity using the Shannon-H diversity calculations to get our final results. And so when we were setting up the transect, we ended up, Jacob noticed a deer skull with fully intact antlers in the distance. So we went over to it, and we were able to extract it out of the sphagnum moss. And I started looking around a little more, and I saw the hips. And then later on, Jacob found the entire invertebrate intact, sunken into the moss. And there was at one point where Fred unfortunately got a little stuck in the sphagnum moss. And so I went over to help him. I kind of dragged him into it a little more.
How about snowshoes?
So you had snowshoes on.
No, yeah, we all have.
Oh, yeah. Yeah, we don't want to break through it, so. Yeah, and so like up there is roughly where the transect was, a little too short to reach. But yeah, come check out our poster over there, and thank you.
I also, after school, run a group called Science Club, and it has a couple wings to it, but one wing has been a program called Sea Perch Aquatic Robotics. And some of the former students who were involved with this 2 years ago got involved with the Sea Perch Aquatic Robotics, and one was in Fred's group with the heath and got inspired by the challenge was to find some real-world application of these aquatic robotics. And Hudson Holden is here, and Ben Humphrey, and Alyssa Mooney. Unfortunately, the third part of the group is not feeling well tonight, so she's not here. But I think this is just being, this is like a dessert now, because we had a wonderful meal, but here's the extra, because this stuff keeps growing. It just doesn't stop with this program. And so they're going to show us what they came up with, what they put together. It was an award-winning project that went on to an international competition, did very well at that international competition. And why don't you guys come on out? You really need to talk.
Hi, I'm Hudson.
I'm Humphrey.
And we did a robotics project. So back when I was a young spry sophomore 2 years ago, I did the Heath project, the same one they did. And I, like they did, tested the surface of the stagnant moss for plants and tested the pH of it to look at how that affected biodiversity. And then later, when we started this robotics competition, we were trying to brainstorm real-world problems that we could build a robot to solve, to apply our engineering skills to make some real change. And I was thinking, what if we could go under the moss and collect samples of what was under the moss and potentially add another dimension of data? So not just the surface pH, but also the stuff underneath it. And so we started on making a robot to collect water samples from kind of underneath them here. And here's our robot, the completed design. And Ben will tell you a little bit about how our water sample techniques worked.
So this was our ROV. We never really came up with a name for it, but all the way at the and it was just outside opposite the green printed off the pieces. There are 2 motors near the bottom. Those are for forward and reverse propulsion. And at the top, directly above the green, is the one here for the
Widget mechanism?
that is our water collection mechanism. So what the plan was is to go under the mouse on the pen, and then we'd activate that with a switch on the controller, and it would just spin the widget pulse all the way down, and we would trap them with some rubber tape. And then we'd be able to remove that and take the water sample and do whatever tests we want with it. Directly above the rear propulsion is the vertical propulsion, and there's a mess of wires all around that. We designed the ROV to be long and lean so it wouldn't get caught on anything. I think it worked pretty well.
Absolutely. Yeah, so we have a little video of our robot doing its thing. One moment. So here's a robot in the pool environment that we have, and you can see it making its way under this moss. This is moss. And I can see we have this little plastic tube, which is our second water sample collection design. And I'm extracting water directly from a tube along the ROV all the way up back to that syringe, where you can then deposit it in the tube and run tests on it that way. However, a disadvantage of that is that you can't collect larger particulates in there, you can only get things that can fit through the tube. So we designed our second water sample collection. And now you can see me here removing this sample, and those 2 balls on the side have closed after the robot has gone into the water. And the tube has collected water and then dumped it into a second pile. So we have 2 methods of collecting along that way. And so we went through a lot of challenges in this design, including adding a 4th switch to our remote, which can hold the solder at a time. Here you can see that secondary widget vault contraption close a little better. In slow motion. And so, yeah, that mechanism, it took us a long time to design, and it was inspired by this Van Doren bottle. This bottle generously donated, we generously said was part of it. Not donated. Robots are easy, English is hard. And so, yeah, we took that kind of design and shrunk it and threw it on the robot.
I believe the way you found the faces of the wires is by just randomly testing it as well.
Yeah, a little bit of testing. But it's all well and good to do it in a pool and see what you could do, theorize, but I wanted to go out onto the fen and do some real science. And so I went out there with the help of Mr. Evans and Caroline, and we took our robot and threw it in the fen and collected some data. And so this data isn't scientifically rigorous per se, it's just a way to test our robot and see what it can do, but we had to go out into the fen and out into the core behind it in order to collect some water samples. And so you can see our data here. You can see this is some water collected from the fen and ran some tests on it. And this just proves that our water sample collection system not only works, and that our robot can be maneuvered and operated, and it all works. So thank you very much.
You guys still have the video of the robot actually going into the fan?
I didn't believe so, no.